Now that's sending waves in the other direction, the opposite angle. They're taking over now, and they're now established, and you can see a wavefront going away from the camera. So those are the elementary building blocks of the sea state, which might be made of perhaps 75 different wavefronts of that kind. Now we've got two added together. We've now got 8 numbers defined, 2 frequencies, 2 amplitudes, 2 phase shifts, and there's the quilt. So angle, amplitude, frequency and phase are specified. Energy from 2 directions. If the frequencies were slightly different, the pattern of the quilt would slowly move at the frequency difference. That's the quilt from above. Now we're putting on all 75 different teeth of a spectrum, all different amplitudes and frequencies and phase angles. And that's a realistic bit of mix C. We're about to expand the computing system to make perhaps as many as 1,000 different fronts. It's a pseudo-random C. It will repeat at a time that we choose, and if we want to have the same thing again, we can get very nearly exactly the same as many times as we want. What we call the bullseye wave, one frequency from all the wave makers, but the angles are chosen to make them, the fronts converge at one point in the tank. And we have although this is in deep water, going down below where you can see it's a plunging breaker, even though it's a regular wave. And it's a good way to make a lot of wave energy come to one place. You can get a wave, if you really push it, about the same as the hinge depth of the wave maker, which is really pretty frightening. That's it slowed down a bit, and even slower. Very close to the predictions made by Longet-Higgins and Coquelet. This one steepness, limiting steepness of 1 in 7 is not true if you can fiddle the directions. That's a slowed down view of it. Quite frightening to be in, even at 100th scale. Now, this is a wave which is supposed to represent the Scottish flag, patriotic gesture, St Andrew's Cross there. Some other national flags are a little harder. Now we've got a random C with a rather malevolently chosen group of phases to sink the trawler like that. Here's a view of the same thing from above. And we can make it capsize bow over stern. Unless the Duke of Edinburgh is watching, when it doesn't work. Here's another shot in about real-time speed. We've slowed the camera down. Sorry, we speeded the camera up so that the time is slowed by the square root of scale. And here comes the wave. Now, I think, there we go. And another trawler half a mile away would not have been aware of anything really special happening that night. They just lose radio contact. Same shot again. Watch the mast. Landlubbers laugh when they see that, but people who've been to sea maintain a stony silence.